Good morning, one and all. I welcome you all for the lecture series 4. Today we are going to discuss about hardness testing of materials. So we all know what is basically hardness. In the class we have discussed what is hardness with an example of mechanism of metal cutting. So let me repeat that for your better understanding in this lecture series. So whenever you take a material which is to be cut in the lathe, we have something called cutting tool. We call it a single point cutting tool, which is fed against the rotating workpiece that is held in the chuck. So the rotating workpiece gets cut because of the contact between the single point cutting tool and the specimen. So how a material cuts the other material is basically hardness. So hardness is the ability of the material to withstand scratching or abrasion. So we test this hardness using different machines, and one of the testing is nothing but Brinell hardness testing. So let us have a look into the Brinell's hardness testing setup. So this Brinell's hardness testing is having a column, C column, where there is a hardness dial and there is a test point. We can keep the sample material here in the anvil and the table which is holding the anvil, and we have the handles to raise and lower the anvil, right? So what is the basic difference between Brinell harness and Rockwell harness is nothing but the load application. So we can here for higher loads we can't prefer Rockwell harness. We have to go for Brinell harness. So we have some hydraulic system behind this Brinell to apply more load, that is more than 400 to 500 kgs. So we prefer this Brinell hardness testing. So it is a test method for measuring hardness as we explained. It involves applying a known load to a material and measuring the diameter of the indentation left by the indenter. And the test is named after its inventor Johann August Brinell. So let us see what is the step-by-step procedure of Brinell hardness test here. So a Brinell hardness testing machine is used consisting of load application system, a hardened steel ball as the indenter, and a measuring device to determine the diameter of the indentation. So how will you select this indenter? It is usually selected which can vary in size, that is diameter, depending upon the expected hardness range of the material being tested. The commonly used ball sizes ranges from 1 to 10 mm in diameter. So next comes the test specimen preparation. The material to be tested is typically in the form of flat surface such as metal piece or casting. The specimen should have sufficient thickness to prevent deformation during the test. As it is discussed already in the Rockwell test, the same procedure is followed here in the test specimens preparations. If the surface is rough, it may be smooth or ground to ensure proper contact with the indenter. So what is the procedure behind that is it begins with applying a known load of specimen using the testing machine. The load is maintained for a specific duration to allow sufficient indentation to occur. The duration may be vary depending on the material being tested and the expected hardness range. The next step is indentation measurement. After the load is removed, the diameter of the indentation left on the material surface is measured. As we see a beautiful picture here, we have a carbide ball indenter and a specimen surface. When the force is applied or the load is applied, indentation of the indenter with the test load is being seen here. And remaining indentation of the surface A is typically shown here, where the diameter of the ball is getting impressed inside the specimen. So calculation of hardness is by dividing the applied load by the surface area of the indentation where we can get the desired hardness. We have a standard hardness formula for this where HB equal to 2P divided by pi d on to d minus root of d square minus small d square, where HB is nothing but Brinell hardness number and P is applied load in kilogram and D is the diameter of the indenter and small d is diameter of the indentation. So this is how we can calculate Brinell hardness number. So this table shows what is the type of indenter and the side view of that and top view of that and total number of loads which can be applied for this Brinell hardness test and the formula for calculating hardness. So here we have a 10 mm steel ball or tungsten carbide ball which is being used, and where the diameter of the indenter is shown in capital D and small d is the diameter of the indentation or the impression happened on the material. So the loads applied here are 500 kgs, 1500 kgs and 3000 kgs. So when we compare this with the Rockwell hardness tests, it is almost 5 times. So the application of load can't be using a spring or some other means. Here we have to go for hydraulic application, or we can use piston and cylinder arrangement to get this amount of load. It should be precisely applied. As we discussed, hydraulics is more precise than pneumatics. So you can upload up to 3000 kgs of load upon the specimen. That is how we can take the indentation. And substituting in the formula, we are going to get the Brinell hardness number. So in this way, the hardness being tested. So thank you all for being in the lecture series. Save trees, save nature.